or two blanks down there for that geometric piece, series summation. You know, we didn't need the two for the arithmetic. There's only one formula for arithmetic. It has to be finite in order for us to find it, which means it has to be countable. It has to stop somewhere. That's not the case with geometric. With geometric, we get two different formulas. We have one formula that we can use when our sequence or series stops, and that's called the finite geometric formula. And then we actually get a formula for infinite geometric series, and probably we won't do that one until tomorrow. So geometric series are objective to define geometric series and find their sums. But we already know what they are. We talked about geometric sequences before. They have to be multiplied by the same thing every time. That's what's going on here. But it's the sum of those terms in that sequence that's important to us when we talk about series. What do you get if you add them all up? Pretty obviously, the numbers are going to get huge really fast because we are multiplying to get that next term. Now, the good thing, well, the formula looks awful, but really, there's very little we have to find in order to use the formula for the sum of a finite geometric series. If we have a finite geometric series, and yeah, they're making this look much more difficult than it needs to be, where you have the first term, then you multiply by r to get the second term, you multiply r again to get the third term, then our formula is s sub n. Okay, so are they going to tell us n? Sometimes they won't. Sometimes we'll have to figure out how many terms we're talking about. A sub 1, that's the first term. Generally, that's going to be given to us. Parentheses 1 minus r, we can find that. We've been doing that all through the chapter. All we have to do is take any term and divide it by the term before it, and we can get r. And like I said, that n, sometimes we're going to have to find. But there's r again. We don't have to know the last term to do this. We just have to know which term it is, what number term it is as we go through it. So a sub 1 is the first term, r is the common ratio, n is the number of terms. Flip to that front page, and in those two blanks, for series summation for geometric, we are going to put finite in one of those. This is the finite geometric formula. And this is what it is. And we'll grab a highlighter and we'll color all the stuff that we're going to have to find. So this is finite, which means it stops. We know we're going to do the first 10 terms. 10 terms stops. That's when we want to use finite, meaning countable. It does stop. So what do we have to highlight? Well, we need the n. Maybe I can find my highlighter up here. I don't want this to be too huge. There we go, I'll use that one. We need n. Gonna have to find that. We need the first term. Well, they gotta have a first term to show us how the series starts, you know. And we're gonna have to find r. So those are the pieces that we have to figure out. And again, we don't need to know what the last term is. That has been a stopping point for us when we've been working with arithmetic, where we had to say, okay, now I'm going to figure out what that last one is. I've got to use my rule, my formula for arithmetic sequences to figure out what that last term is. Don't need it anymore. Looks complicated. Kind of complicated when you go to punch it into the calculator, but literally that's about all the math we have to do is just plug the numbers in and then get it into the graphic calculator and make sure we can calculate it correctly. So, everybody got that on the front page? I'll highlight it, ready to go? And let's move on. Notice immediately, problems. No more yakety yak. I like that. Here's the math, now do it. No more blah, 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 blah.
Right on.
What is the sum of the finite geometric series? Bam! Right there. I'm going to let that formula guide me. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. That tells me what I have to find. So let's see here. I need to know, how many? I don't know how many. Well, this is very similar to arithmetic in that if we don't know a piece of information, we're going to go back back and use the rule, the formula that we use for geometric and find what we need. That's what that's for. If something's missing, we're going to find it. Now, do you remember what we had to put into this formula if we wanted to use it? Two things. What two things do we have to put into that formula if we want to use it? A sub 1 and r. All right, so a sub n equals, good news, first term's right here, it's 3. Good news, finding r is not difficult. 6 divided by 3 is 2. And here's what I need to know. Which term that is. That's what I need to know. What that we have over there stands for something we could put 3072 in for. Yeah, this is saying any term. There it is. It's 3072. Well, now we can work backwards. And we've only got one variable there. Let's see. Well, we divide by 3. So 3072 divided by 3 is how we would start. And that would give us 1024. And I just had the realization that, again, we haven't learned logarithms yet. But we can do a little trial and error. 2 to the something is obviously 1024. We just need to figure out 2 to the what. So let's try a couple things. 2 to the 9th, 2 to the 10th. Aha. So we would need to put a number in here that would make that a 10.
Thanks, Eli.
So n is 11. We just got that last piece of information that we needed for this formula. So the sum of the first 11 terms, where the first one is a 3, they're multiplying by 2 every time. 11 terms over 1 minus 2. I never punched that whole thing. I don't. We can do 1 minus 2 in our noggin. That's negative 1. 3 divided by negative 1 is negative 3. I would punch this in instead. A lot easier than punching that mammoth business in there. Because you would need parentheses here, and the parentheses that they already have. If you love parentheses, hey, more power to you. Go ahead and punch it in that way. But I'm going to simplify a little bit and do negative 3 parentheses 1 minus 2 to the 11th power. Whoa, that's pretty big.
Yes.
Supposed to be?
Yes.
Better be. We're talking geometric here. These are going to be large. They are. In fact, this might be one of the smaller ones that we deal with. Formulas. Big time. Formulas. So is B going to be more difficult because we have this in sigma notation, or is it going to be easier? Well, let's see. This is still sum, and I look at it and I know it's geometric, and you should too, because look at this. A sub 1 times r. It's supposed to be an n minus 1 though, so maybe we better be a little careful with this, but this is still a sub 1 and this is still r. So let that formula guide you as to what you need. When that lower limit is not a 1, do you remember how we can find the number of terms? (20 minus 0) plus 1. So we still know there's going to be 21 terms. Find the first term. Actually, a couple of ways we can find it. We should know, hey, it's right here, it's 4. But let's just say we don't. The other thing we could do is say, well, if I put a 0 in here, I'll get it. Because that's the first number they wanted me to use. So anything to the 0 power is 1. 1 times 4 is 4. 2 ways to get the information we need. R. What's being raised to the power? That's always R. 1/2. We already said we needed 21 for n. So again, little math to do in the noggin would be this one down here, where I say, okay, 1 minus 1/2, that's going to be 1/2. Dividing by 1/2, that would be silly. This is a fraction. I can just multiply by 2. So this will be the sum of the first 21 terms by having an 8 in front, because 4 divided by 1/2 would be 4 times 2. And yeah, the rest of this, you just have to be really careful punching it. Everybody okay with where my 8 came from? Just did this little piece right here. In my head, right there. So multiply by 2. So calculator, help us out here. What is 8 times 1 minus 1/2 to the 21st power? Oh, super duper close to 8. How many 9s we've got there? 1, 2, 3, 4, 5. Approximately 8. So first 21 terms, about 8. You know, really, really super close to 8. So now, we have these, which normally, I'd give you candy partners and we do all that, but we got 36 minutes today. So instead, let's get rocking on this and I'll just ask people questions. Finite geometric takes us right here. Looks like so. So my first question is going to be, how many terms are we supposed to add together? 6? Well, how'd you know that? You can just count them. All 6 of them are right there. So sum of the first 6 terms. What's the first term? -15. What is R?
Times -2.
-2.
Yeah.
And we said we're going to do that 6 times.
I got it.
All right. Now let's do that little bit of math in our head so we don't have to punch it in. 1 minus -2 is 3. What's -15 divided by 3? Much easier to punch that in. Go ahead and punch it in. Tell me what you get. Be careful with the negatives. If somebody messes up on this one, it's usually because there's quite a few negatives to keep track of. That looks. There, that's better.
The 6th power. Close brackets. Now.
What we got, everybody?
I got 315.
Joe got 315, everybody. 315?
What?
It is
What did I
315.
punch in wrong?
It's 315.
Oh. It's 315?
It's 315.
Yeah! 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 I'm a master of punching. Yeah!
Really important that that -2 is in parentheses. Really, really important.
I want to see what happens.
You can't.
Yeah.
Here's why. Jessica just asked the best question here. She said, but can't you just change this to addition? We can't. Oh, add them all up? We're not supposed to do that. But yeah, we could, because they gave them all to us. But we're supposed to use the formula. Here's why. You'd have to do this power first, and that makes this by the order of operations. That makes this positive. So it's 1 minus that number as you go through the
Why can't you
sum.
just do -15?
That's what Jessica just said, because we're not supposed to. All right, try this one. Try the one with the sigma notation. See how that one goes.
I have errors.
How many terms, everybody? 10. 10 minus 1 plus 1.
10.
First term is a 5, staring us right there. A sub 1 times r. So what's r? Got to be careful with the negatives again. So give me the math that you're going to do in your head to get that front thing to multiply by. 5/3. Yeah, it's not as pleasant as the other ones were. 100. Let's see what we get.
Hang on, now I gotta punch it in. I'm not punching math.
But I'm gonna say negative 1,705.
Everybody getting it this time? Be careful with the parentheses, especially when there are a lot of negatives. Be careful with the parentheses. So now we're going to look at one of the all-time best series questions ever. It's a myth slash. I already got that joke.
Oh.
Great.
I was still punching it in.
The soldier's reasonable request. A famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason. He can't, say, I want to be king. The king's not going to give him that. So, within reason, from the riches of the kingdom, the soldier asks for a chessboard. Single kernel of wheat on the first square. But then he wants the king to double that kernel of wheat for every square on the chessboard. So first square gets 1, 2 kernels on the second square, 4, 8, and so on for all 64 squares of the chessboard. The king decides, sounds like hardly nothing. What's this guy doing? He saved my life. He could ask for anything. Okay, 1 kernel a week, 2 kernels a week, 4 kernels a week, 8 kernels a week. Not a big deal. So let's just see. Is it a big deal?
Got it.
According to the story on the preceding page, how many total kernels of wheat did the soldier request?
It's a big deal.
Well, it's geometric.
It's a big deal. This is a big deal.
And there's 64 squares. But the first square, 1 kernel of wheat. But doubling it for every square. So what should we put in front, everybody? -1. Punch that in and see what you get.
Come on, don't say without me this time.
That's still a big number.
No, I clicked something wrong. Oh, I don't think I did that right. I was rushing too fast. I got 1.844674407, and then scientific notation at 19. Yeah, so 10 to the 19. 10 times 10.
Let's put the zeros on like we're supposed to. Let's just say we wanted to know how many total kernels of wheat this is. Well, let's see. Got to move that decimal over 19 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
How many zeros did you have? 10? Okay.
Whew. Sounds like a lot of kernels of wheat, but wheat kernels are teeny. So maybe that's not a lot of wheat kernels. Well,
Ha!
You got whatever.
Wow!
flip the page.
That's a lot of kernels. That's not even that much. But I mean, really, it's only a couple zeros. I mean,
The rest of the story
Think about
is
it
a
as like
bushel of
only
wheat
like a row of
contains
kernels.
about 1,000,000 kernels. 1 bushel a week of wheat is 1,000,000 kernels. The total U.S. output of wheat in recent year was just over 2.1 billion bushels. Whole country, 2.1 billion bushels. How many years of production would the United States have to grant this reasonable request? Well, let's start with his I will just go with 1.85 times 10 to the 19th. Kernels. And I know this will make you very happy. We're going to use a little bit of unit analysis here, which you've probably been doing in science class, which is called dimensional analysis in science class. So I don't want my answer in kernels. What I want is to compare this to what we have with the US. So what I have to do is look up there for something about kernels that would lead me to something else. And it said, yeah, we got kernels have to cancel out. So kernels were on the top before, kernels are going to have to be on the bottom now. And that's going to be 1 million kernels in one bushel.
Why not like 1 bushel per square, like doubling that? Oh, that would be a lot.
See, they would have known that though. The king would have been able to figure
How
that
about like
out.
2 kernels per square?
Well, you wait, he still asked for a lot. So now what I have to do is figure out how many bushels we're talking about here. So I go back up here and I realize in 1 year, the US produced 2.1 billion bushels. So I need something with bushels down here. 1 year, 2.1 billion, that'd be billion. There's your millions. So that'll tell us how many years it would take for the United States to grant his request. Oh my.
Calculations.
So let's take this
He messed up. Hold on.
and divide it by, because with fractions you always do top times top times top, divided by bottom times bottom times bottom. 1, 1, 2, 3, 1, 2, 3 times 2, 1, 0, 0, 1, 2, 3, 4, 5, 6.
Not 0.
They don't have calculators back then to figure out.
Divided by point
Well, then,
1. Divided by 1.
What's the label that'll be left if we cancel labels top and bottom?
years.
Years.
Oh my goodness. This is a big number.
Our entire country would have to produce wheat at that level for 8,784.2 years to get enough wheat to grant his reasonable request. Sounded reasonable, but here's the thing. The guy wouldn't have lived very long once the king figured out what he'd done. You don't trick the king. You don't do that.
What happened? He
It
died
just
somehow.
doesn't work. Just by accident,
That's
he
what he
happened to
knows.
pass away.
Oh, don't look back here. This is the guy that sold it.
He would have just told the citizen that he died of a disease.
There you go. To save money for a vacation, you set aside just $100, $100. But each month thereafter, you're going to take your $100, you're going to give another $100, but you're going to also increase it by 10% more than the previous month. How much money will you save in 12 months? The key to this one is knowing that our R value is 110%, because they're not just saying they're only going to put $100 in and then put 10% in. They're saying I'm going to still put my $100 in, but I'm also going to increase it. So if we want to know over the 12 months how much they save, we use our formula. First month was 100. 110% is a decimal, everybody. 1.1. Going to happen for 12 months. This one, again, I mean, it's decimals. People aren't real comfortable with that. But if you realize it's 1 minus 1 and 1/10, you'd have a negative 1/10. And when you divide by a negative 1/10, this will become a negative 1,000. Or you could just punch it all in. So go ahead and punch it in and let's see how much money we have after 1 year.
Got it.
12 months.
Hang on. No, I know I got it.
Dollars and cents if you need to know.
To the 12th power. Closed with. Well, I got to the 10th.
12.
No,
Yeah, I think you put your parentheses
No,
in there.
what place? Tenths.
Tenth place.
Oh,
Yeah.
money.
Oh,
Same
hundreds.
thing,
yeah. So I got a 2,138 and 43 cents.
Wow. You
Yeah. So,
I heard that.
good way to save for a vacation. You know, just say, here's what we're gonna do.
conflict. Whoa.
43210, me, our objective was to use our geometric series today. Feel about our not so little formula. Yeah. Would you say the formula's not bad, but punching it in can be a hazard? Yeah, that's the problem with this formula. It's a pretty basic formula, but boy, if you punch it in wrong, you are toast.
Here, let me show you something that is so neat.
There you go. You have a question, Eli?
No, I'm just like, number one.
Random